Hi guys, welcome to my YouTube channel. Today we are going to solve the problem of the day by the GFG, and today's problem name is queue operations. So let me read the problem statement. Given n integers, the task is to insert those elements in the queue. Also given m integers, task is to find the frequency of each number in the queue. So basically क्या बोला गया है कि हमें n integers given है, हमें उनको क्यू में इंसर्ट करना है। उसके बाद हमें m क्वेरीज गिवन होंगी जिसमें हमें m queries given होंगे एंड इन ईच क्वेरी वी विल गेट अवर नंबर और हमें उस नंबर की फ्रीक्वेंसी को फाइंड करके बताना है क्यू के अंदर लाइक दैट पर्टिकुलर नंबर इज एग्जिस्टिंग हाउ मेनी टाइम्स इन द क्यू दैट वी हैव टू रिटर्न फॉर ईच क्वेरी एंड टोटल m query would be asked like is example for example in this particular test case my in the first query I am getting number 1. So how many times 1 is existing in my queue? So 1 is existing 2 times. So we got 2 for the first query. Second query, we are getting the number 3. 3 is also existing 2 times, so we are getting 2 again. Then in the third query, we are getting again 2, and 2 is occurring 2 times, so we are getting 2 for the 2 as well. And 9 and 10 are the numbers which are not there in the queue. If something which is not there in the queue, for that we have to return -1. So that's how we have to do. And if we look at the code, then we are supposed to implement our code inside these two functions. So inside the insert function that we have to do, we have to insert this key element inside our queue, and here we have to check the frequency of element k inside the queue. So how can we do that? Let's say we know that insertion is just q dot push operation we know in queue, and it takes just a constant time. But in case to find the frequency, uh, either we can use a hash map in the starting and just return the frequency in a constant time. But if we look at the expected time complexity, it is just n cross m. It means that we can, for each m is the total number of queries, and we can say that for each query, we can require big of n time to solve. So instead of using a hash map, we can directly iterate over the queue and check the frequency of element key. We don't need any extra space for the ordered map or the hash map. So let's look at the code now. So this is my code. Like in order to insert any element, I am just using a push operation on the queue to insert the key into it. But when I'm using this particular function, let's look at the find frequency function. So inside that, what I'm doing, I have to actually find the frequency of element A inside my queue. So what I'm doing is I'm just iterating over the queue and finding the frequency of k. At the end, I'm just checking if the frequency is equal to 0, it means that particular number is not occurring inside a queue. Then I will return -1, else I will return counter. But the thing is that how can we iterate in the queue? Let's say my queue contains the 1, 2, 3, 1. Let's say these are the numbers that my queue contains. And I wanted to know the frequency of 1, let's say. And I wanted to know that in the query I got 1. Wanted to know the frequency of 1. So how can we do that is we can actually, there is no way to iterate through the indexes in a queue. So I have to push the front elements. First of all, I will just check the size of the queue. Initially, the size is 4. So I will perform the push and pop operation for the 4 times. So I at the first index, for the first time, what I will do, I will push the front element and check whether it is equals to query or not. And after that, I will insert it into the back. So yes, it is equals to query. So my counter or my answer would become 1 here because it is occurring for the first time, or we can say 0 plus 1. Earlier it was 0. Earlier initially my counter was 0. Now I'm getting 2. So 2 is not equals to the our query value, that is 1. So I will just pop it from the starting. I just pop it from the starting and pushed it into the back. So my query remain the 1 here. Now we have the three element in the front, so it is again not equals to our query value, that is 1. So we'll just pop it from the start and push it into the end, and still our count is 1. Now we again get a 1. So this is actually equals to our query value. So this time I have to increment my counter, and I have to pop it from the starting and push it into the back, and I got counter is equals to 2. 1 plus 1, that is 2. So you can check it out. This is my original queue before performing the searching operation or before counting the frequency. And after, like I have to do this operation for the size number of times, that is very obvious. And after performing these particular operations, after iterating over the queue, again I get my original queue format, queue arrangement, right? This is because we have rotated the queue n number of times. So if we are rotating our queue cyclically n number of times, we will get the same queue because the size of the queue is also n. And that's how we have actually iterated also our queue, and we got the frequency for our number. So this is the why we are doing this particular operation. This is actually rotating our queue cyclically in the clockwise order, and we that's how we can keep the count of our query number also along with it, and at last we can return the answer. So this is the code for this particular problem. Thank you guys for watching this video. If you like this video, then please hit the subscribe button, and if you have any query, write it down in the comment section. Thank you.